This is Elohe Amini about SPI questions, frame rate and temporal resolution, part 2. If the frame rate is 30 images per second, and each image or frame has 100 lines, the transducer frequency is, yes, none of them. It is very important. The transducer frequency is determined by the electrical voltage in continuous mode and in pulsed echo transducers by the thickness of the active element and the speed of the sound in the element. So frequency is different from pulse repetition frequency. Pulse repetition frequency is determined on the lines and frame rate. What is the fundamental limitation of the temporal resolution? Yes, it is the speed of the sound in the medium. You can change the speed of the sound in the medium, but you can change the sector size and line density. So it is a fundamental speed of the sound in the medium is a fundamental limitation of temporal resolution. In heart scanning, due to high rates of motion of the heart, the fundamental rate is higher because it moves very fast, and we need for each moment of changing position an image to have it very accurately. So it is 50 hertz, but typical ratio is 30. For eye flickering is 15. At least 15, but typical 30 for hard 50. What is the typical rate of the frame rate? Yes, 30. Standard frame rate is 30 hertz. What is the least rate of the frame for the human eyes that are not flickering? Yes, 15. So typical is 30, but prevention of the flickering for the eyes is 15. How many fields of view per second hertz is necessary to make 30 hertz frame rate? 60, because as you see in this picture, odds and even fields together makes one frame. So the number of the fields are 2 times of the frames. Fields and frames. Which one of the following image has the higher frame rate? Assume the image depth, number of the focus, medium speed, and sector size are the same. Right, because the right has less line per degree or less line density, hence less time to finish each frame. With higher frame, each unit of time, like per second or hertz. Which of the following sector imaging systems will have the best image frame rate or temporal resolution? Other parameters are the same. 60-degree sector, 90 pulses per image. 90 sector, 100, 60, 60, 80, 40. Yes, D. You should choose the one that has less line per degree. So for A, 90 pulses divided by 70 degree is 1.28 line per degree. For B, 100 pulses divided by 90 degree equals 1.11. For C, 60 pulses divided by 60 degree equal 1. 1 line per degree for D, 40 divided by 80 degree equal 0.5. So D has the best improved frame rate, but degraded spatial or detail. Which of the following sector imaging systems will have the best image detail? Other parameters are the same. The image above can help you. Yes, the choice that has more line, nearer line together to have better lateral resolution or spatial resolution. Here we have three sectors that are equal degrees. The first one has only two lines, so shorter time to create each frame. The second frame has three lines, more time to create a frame. The last one, more lines, more time to create a frame. The first and has the best resolution. The third, the worst temporal resolution, because more time for each frame and lower frame rate, degraded frame resolution or temporal resolution. A spatial resolution or detail of an image is opposite to the temporal resolution or frame rate. The first, low line density, low spatial resolution, but improved temporal resolution, less time to take one frame. Time is critical factor in determining yes, all choices. When you increase the lines per each degree, or you increase line density, or you increase depth, time for each one to create one image increases. So when time increases, spatial resolution improves, but temporal resolution or frame rate decreases. If manufacturer increase the number of the line per frame for prevention of temporal resolution degradation, which of the following should be decreased? Sector degree, depth, frequency, pulse repetition frequency. E, A, and B. Yes, A and B. Because if you decrease sector degree, it needs less time to create one image. If you decrease depth, you increase pulse repetition frequency and less time to have one frame. But frequency does not depend on them. In the question, it speaks about decreasing. So a pulse repetition frequency should increase to improve frame rate. So only A and B can decrease to improve temporal resolution. And frequency or fundamental frequency or central frequency of the transducer does not dependent or can't improve or degrade the temporal resolution too much. The point is PRF should be increased. Imagine you are changing depth. The point is PRF should increase. Remember, with decreasing the depth, you can increase the PRF. Decreasing degree of sector, decreasing the degree of sector from here to here improves temporal resolution. Decreasing the fundamental frequency does not have better effects on the frame rate. Penetration increases. So maybe if you decrease frequency because of improved penetration, there is much time. It is like increasing depth. So it degraded the frame rate. With multifocusing systems, which resolution will improve? With focusing, You have less area. Less area improves lateral resolution. Yes, correct. Mm. Temporal resolution and frame rate will be decreased with multifocusing. It is very important. It is also about the spatial and uh, or lateral resolution. Uh, so it is very important. So every time you hear about the spatial resolution, think about the number of lines that if increased improve spatial resolution, and also lateral plus axial resolution, both of them are a part of spatial resolution. Which resolution will be directly affected when you decreases depth? Temporal, azimuthal, range, contrast. Yes, temporal. Because when you decrease or improve, you decrease or increase the depth, you increase or decrease the time. So time of each image changes. So temporal resolution will change. What is the relation between pulse duration and temporal resolution? It is very important, unrelated. Pulse duration, please imagine this part is pulse duration. Pulse duration is the number of cycles times period. It is related inversely with axial resolution, is not adjustable, and is not related to temporal resolution. It is not total. Total is pulse repetition period. But pulse duration or pulse length is this part. What is the relation with pulse length and temporal resolution? Pulse length. Yes, it is unrelated. Here is pulse length again. Wavelength, each of them are wavelength times the number of cycles. It is like pulse duration, but duration is time, but here is length. Length can change with medium to medium, to other medium. We can change it. It is not adjustable, but it depends. It is the spatial pulse length, and pulse length or spatial pulse length, number of the cycles times wavelength it is inversely related to the range or axial resolution, not temporal resolution. I hope this short video helps you to be ready for SPI for this difficult temporal resolution questions.